Hello and welcome to part 2 of the Advent of Code Day 10, 2021. So for part 1 we had only to detect when a line composed of parentheses has a parenthesis that is unbalanced, so essentially a closing parenthesis that is not matched by a corresponding opening one. For the part 2 instead we are asked to find when a string of parentheses ends and some parenthesis is left unclosed. We have to calculate the score of the remaining parentheses in some complicated way. So first of all, we have to notice that the lines that we have to consider for this second part are exactly the ones that we didn't consider for the first one, because the first part wanted to asked us to find all the closing parentheses that were unmatched. Now we have only to consider the lines that do not have an unmatched parenthesis, so the lines that are valid so far but need some closure essentially. After we do, we have to find what is that closure, so what are the parentheses that we have to add to complete the line, and then calculate a score in a very convoluted way. So let's see what we have. First, let's just copy the part 1, because a good part of the problem is similar. So as you know, for the part 2 we still receive the lines, we still process them. Every time we find a line we go through it and we keep track of the openers that we found, so all the parentheses that are open parentheses. If we find a closing parenthesis, we have to match it with the last opened one. If it matches, so if we are closing parenthesis that was the last one being opened, we go forward. If not, we break. Previously, we did care only about the failed matches. Now we don't anymore. So what do? I remove this score calculation that was for the invalid characters, because we don't care at all in part 2. And now I break when the parenthesis is not valid. But now I want to do the opposite. I want to detect when the for cycle ended without breaking. So the for cycle went through the whole line. How I do that? There are many ways. One way would be to have Boolean variable to flag whether I exited or not. But Python has a very interesting function that is not very well known, which is the else on the for. So notice that this else doesn't match an if, but a for. What does it do? This is executed every time we do not have a break, which means that it is executed every time the for cycle reached its, how to say, natural end, instead of being closed prematurely by a break. In our case, we reach this point when there were no closed parentheses that were unmatched. So essentially we found an incomplete line. Now, how do we detect, how do we build the autocomplete? How do we build the completion of a line? That's simple, because opened, we know that contains all the parentheses that are waiting to be closed. We previously used that just to know whether a closing parenthesis that we find is matching a previously opened one, but now we just use it as the list of the parentheses waiting to be closed, so the completion of the line. If we add this opened parenthesis back to the string, we basically have always a complete, perfectly closed set of parentheses. One thing to do is to reverse the opened list. Why? Because the problem is asking us to build this string, the closing parenthesis string, but in reality what we had was a reversed list, because what we care about is what is the last character that we opened, but now we have to close the last character, so we have to make the last element of our list the first one of the new list. So we reverse it. Then we are asked to calculate the total in a very strange way. Also now parentheses have different scores, because previously we had this score, now for some reason we do not have the same, so we cannot reuse the dictionary created in the first part. Fine. So let's calculate the score. So the score initially is 0. Then we have to go in the closing, in all the characters in the closing parentheses. So for character in opened, what do? We have to start with a total score of 0, which we do multiply the score by 5. So score multiplied equal 5. And add the value of the closing parentheses. So I say if C, which is the character closing, is equal to the closing parentheses, score plus equal what is, so the round parenthesis is 1. Here I could use a dictionary, or yeah, let's use a dictionary. So let's call it scores 2, because it's not anymore the same scores. Scores 2, very ugly, but it works. It's 1, 2, 3, and 4, I think. 1, 2, 3, 4, yes. So score plus equal scores 2 of this value C, and so we multiply, blah blah blah. Okay, then what we do, it's a very strange way to calculate the score. I don't know why it's so convoluted this time, but okay. What we're asked to do is to keep the score for this set of parentheses that we found. We add it to the total, which is not anymore a single value but a list. So we do total dot append the score, and then we what we have to do, we take the middle score, and that's the result. So after we do all this stuff, we have the lines, we have all the scores, we sort them. So sort total, sorted total. So we just sort it, and we take the middle. So return total at the position length of total divided by 2. Total will have, so the problem says, always an odd number of elements. So the length will be an odd number. So we divide the 2, keeping the integer. Let's try to run it. And we have a problem, because the scores are calculating on the closing parentheses, but actually what we have in the list are the opened ones, which is completely fine. We are just matching one by one, so I simply put here the opening parentheses, and that's it. Because in opened we store the opening parentheses, and in the previous problem we matched them using this dictionary, but in this case we don't, so we have to either reverse the scores to the matching parentheses or apply the pairs to find the closing parentheses and then find it in the scores, but I prefer to just change the scores. So I run it and I get this value. Let's see if this is correct. Yes! So thank you for watching, hope you enjoyed the video, and see you for the next part. Bye!